it observed about what we got from the score, and true is actually what it's supposed to derive.
Okay, Dharni.
True score is what the actual score of the person after calculating the adding up all the items in the questionnaire.
Okay. Okay, so true score is basically a hypothetical concept. So true score is something, one absolute measure of a test when there is no error. But can it be in real world that there is no error? It can't be, right? So reliability is, we were saying, so it's the variation of true score upon the variation of observed score. So hypothetically, we are thinking that there must be a true test or true instrument of measurement where it is absolutely error-free, not even a single error. So if we measure any construct on that scale, and then we are measuring the same construct with our instrument or with our scale. So when we are measuring it with our scale, there is a certain percentage of error, which can happen because of the methodology, because of the, like there is random error, there is the concept of random error, and there is the concept of error which is forming because of the instrument itself, because that instrument is not error free. So are you aware of the this measurement error concepts, right? You have a little idea about measurement error concepts, right?
Which one, ma'am?
Yeah. So suppose random error, suppose I am trying to measure height of a person, and that person is somewhat not standing in a straight position. So that height what I will be measuring will produce an error, right? So this is kind of a random error, which is arising from the situation or circumstances where when the test is being applied. Okay. So here I was trying to say that this every scale that we develop or every measurement instrument that we develop, it is bound to contain certain error. Now that is our observed score when I am applying something, applying that scale or applying that instrument to measure something. So it's obviously I'm going to have some error, and that is our observed score. So if we calculate the ratio between the true score and the observed score, that will be the reliability of our measurement scale. So our motto is to make my instrument or my scale absolute error free. So I will always try to develop such an instrument which will be most reliable, highly reliable, that is as less error as there can be. Hope I am able to convey the concept of reliability, right?
Yes, ma'am.
Okay.
Shani,
Yes.
question. So
Yeah, please.
see, when we validate any hypothesis, okay, so there is always a threshold or a range is been given, right? A 0.5 confidence or a 5% confidence and all this stuff. So that brings always a perspective of that there is an error. So is it really possible
Right.
to build a tool that is an error-free tool?
So that's what Dharni was saying, that if we try to apply this test, this instrument on a maximum number of people, or suppose we are trying to apply it to the whole population, which is not actually possible. But as much as we can try to apply my instrument to the whole population, the observed error will be less. I mean, I can calculate what is the deviation from the true score. True score is a hypothetical one where I am thinking that there will be no error. Now, suppose I have developed one instrument or developed one scale. Now I'm trying to apply this scale on as much people as possible who comes under my population. Then I can calculate the total number of errors. So I can calculate the variance of errors. So more the number of my sample, that will be almost to my total population, so that I can reduce, there will be a possibility where I can reduce the error in my scale when I am applying it to the very large sample size. But it cannot be totally error-free. That is only a hypothetical condition.
Okay, because my point is the derivation of the true score itself is based on the threshold value, or that the 5% confidence or 10% confidence, right? So there itself we have error has been baked into that. So what we are targeting to get here is with the new, whatever the actual score, what we are getting here is aligning to that, not error free. That's what I'm trying to say.
Right,
okay.
Aligning to that.
Okay.
So what is high reliability? So now high reliability is where we are trying to get as less error or less variance of error as possible. So trying to make our instrument or trying to make our scale as much error-free as possible. And that is to some extent, if my sample size is a very large one, which almost represents my population, then we can develop a scale to some extent. So this is what true score is explained here. So this is basically a hypothetical concept where there will be no error. So I will request you to, once I upload these slides, please go through these slides. And if you have any query, any doubt, you can ask in the next class.
Okay.
Yeah. So this is a kind of classical theory on errors of measurement. So there is a concept of standard error in measurement. So this is a measure of how much measured test scores are spread around a true score. So what is standard deviation? What is standard deviation? You can search it in Google and then you can explain it to me. No harm in that.
You want a definition of the formula?
No, I don't want definition. I want to know your understanding.
Basically, it's a derive the mean and how much each line item is deviated from your mean. Identify that, and so that when you plot the normal distribution, how it's aligned or not.
Right. So when we are getting response from each individual, or say each of my sample, so obviously all the responses will not be in the same line, right? We don't want that also. So from the mean score, there will be deviation, and in standard deviation, we are actually calculating that. So here in standard error of measurement, what we are calculating is, this is the standard deviation of the test, and this RTT, this is the test reliability. So this is like when you are applying the same instrument on the same individual after a certain gap of time. So again, what deviation it is producing from the previous test. So that is the test reliability of a particular instrument. So I'm applying it to one person, say in this month, and again I am applying the same test on the same person, say after 3 months. So the results may vary, right? Results may vary as per the mental state of that person, whether he's tired at that time or fatigue is there or not, whether he or she is in a hurry. So depending on certain aspects, these are the random errors. These are the errors which is coming from the situation or from the environment. So these are random errors. Depending on this, there will be a certain deviation from the in between two tests, right? So in test-retest reliability, we are trying to calculate what is the deviation from one test to another test. So this RTT, this is basically the correlation between this test and retest. So now this standard error of measurement, so this is the standard deviation of the test, and then root square 1 minus this is the test-retest reliability, or this is also called precision of test, or this is also can be found by the variance of true score divided by the variance of observed score. This particular formula we will be getting again in this slide. So let me explain it further in that slide. So standard error of measurement is basically what can be the total measurement of that instrument, irrespective of on which individual we are applying. So we are
Total measure of instrument means, is it meaning is it indicating the total score?
indicating
The total score.
Yes, indicating the total score of a test. So total error in that particular test that we are trying to measure by this formula of standard error of measurement. And there is one more concept which will be there in this particular reliability concept of reliability, that is test homogeneity and reliability. So what do you understand by test homogeneity? What is test heterogeneity? What is test homogeneity?
Homogeneity means maybe the items must be alike. The quality of the items must have a commonality. Not very
right. Right. So this is the correlation between one item with another item in a particular test or in a particular instrument, right? Making sense?
Yes, sir.
So suppose I'm trying to explain this with an example. Suppose we are applying this personality test, and the constructs may be this extraversion Briggs-Meyer test. If we take the example of Briggs-Meyer test, so the constructs are this extraversion, introversion, then thinking or feeling. So then under these constructs, we are again forming certain questions or certain statements or certain items, right? The statements or the questions are items. One statement is one item here in this particular test. So combining these all items, combining this all construct, what is my aim? My aim is to understand the personality of an individual. So my items should not deviate from that ultimate aim. The items should not deviate from the construct which I am trying to measure. So there should be a certain correlation between my items, between one item with the other. If there is correlation, if there exists correlation, then this is homogeneous. If there is no correlation, then it is not homogeneous. So reliability
And how
supports.
do you identify if there is correlation or not?
Yeah, come again.
So how do you identify if there is a correlation or not? Whether we will see the wording or sentence construction, or do we have to do very test for that?
Yeah, there are formula also to calculate whether this what's the homogeneity of a particular instrument.
Would it be use correlation to identify whether there is a homogeneity exists?
Yeah, so we use certain formula to find out whether homogeneity exists between two items or not, and if the items are totally I think last day when we were doing some item that item analysis, that practical session practicum, we found no, there is one certain case where there was some 1 or 0, there was this correlation coefficient was not coming at all, and we need to discard those items if that is the case. In item discrimination, if you go again in those slides, you will see that if the item is so much discriminate that it does not have any correlation with another item, then we are not considering that item for my instrument, because then both these two items are not measuring the same construct. If these are not having any correlation between these two.
Okay.
So if you skip those values, wouldn't we defeat the purpose? Because they are deviating from that, maybe an outlier, they are outlier. So would it cause the impact to the overall reliability?
Outlier in which terms? Outlier in terms of respondents?
No, you mentioned that we will remove them because we are not able to fit them in that whatever we are expecting is going completely away from the relations, whatever you're looking for. So we skip those values. What do you mention? That means they are outliers.
Yeah, so there is, okay, so there is one possibility that the respondent might not have understood the question and responded wrongly. But here in reliability, what we are trying to do is we are trying to understand whether my two items are measuring similar construct or not. I mean, whether when I'm talking about the homogeneity of a test, then I'm talking about whether my two items are measuring same construct personality test, or say under whether two questions are measured. I want to understand. So there are ways to calculate internal reliability. We will be coming to that. There is this contract alpha, coefficient of alpha of this thing, applying which we can understand whether we are trying to my items are trying to measure similar construct or not. So homogeneity here, why this is necessary? Because I want to measure, where is that slide? Yeah, so I want to measure a particular construct. That's why my items should be homogeneous to some extent. Otherwise, it's not measuring the same construct. So homogeneous, if my items are homogeneous, this is my test is more reliable. This will produce more consistency in results. Is it okay?
Yeah, got the point. Thanks.
Yes, ma'am.
Okay. Okay, so there are types of reliability as we were talking about. One is external consistency and another one is internal consistency. So this external consistency is, we will see this test retest. We also try to, I tried to give one example where, like, on the same individual, we are applying the same test after a certain period of time, and my test, both the results should be correlated to a high extent. So higher the correlation between my test and retest results, higher is the reliability of that particular instrument. Making sense?
Yes, ma'am.
Okay. And then there is one more method, which is called parallel or equivalent, where we are constructing two different instruments for to measure a particular construct. Say for personality itself, we have different instruments, different scales, right? So we are forming different instruments to measure same construct, and that should be correlated. Then only we can say that this both tests are going to give me measurement of the same construct. So that is another, this is called parallel or equivalent reliability. Then we will come to this internal consistency is what I was trying to explain, where through homogeneity and reliability. So the items should be correlated with each other, then only it will be having the internal consistency. The scale or the instrument will be having the internal consistency. Otherwise, the scale will not be reliable. Why? Because one of the items is measuring something else and the other item is measuring, trying to measure something else. We don't want such a scale, right? Okay, so this is what is test reliability coefficient. So this is basically the formula of it. So see, test reliability coefficient, it's represented here by Rxx, this one. This is the standard deviation of, this is the variance, sorry, this is the variance of total score divided by the variance of observed score. Now, variance of observed score is the variance of the total score plus the variance of the errors, right? Because in total score, we are not considering error. We are considering that total score is error-free. Now, if I add the variance of error with the variance of total score, this is going to give me the variance of observed score. Take your time and tell me whether I'm able to explain this or not.
I'm lost.
Yeah.
Part is there. Okay. So
Yeah.
let's go by numerator and denominator. So let's take numerator.
Yes.
So
Yes.
numerator, what you are trying to get here is variance of?
This is variance of total score.
Variance of total score. When you say variance of total score,
So what is variance? Variance is the how data is, how that particular data is different from the mean, right? The deviation from the mean.
No,
So
agree.
in
Okay, I got it. Okay.
yeah, so in reliability, my main aim is to understand the instrument or the scale which I have developed. Here in this class, I am interchanging instrument with this term scale. Let's stick to instrument. Suppose instrument or questionnaire, whichever way you want to explain this, you want to term this. So whatever questionnaire or whatever instrument I am developing, my aim is to make this as error-free as possible. So to do that, what I'm trying to calculate is the variance. If there is a absolute scale, absolute, or say, or let's take a more realistic example. Suppose I have developed a new scale on personality, and there are certain already established instruments or established questionnaire to measure the same construct, right? For personality or to measure attitude, there are already approved construct which is there in the market, which is there in the for all the people to apply. Okay. So suppose I want to develop one more questionnaire or one more instrument for myself. I found that that is not enough. I want to develop something on my own. Now I shall take an already reliable and valid instrument, and I shall apply that particular already valid instrument, already reliable, which has already approved, which has been already approved as a reliable and valid questionnaire, reliable and valid test or instrument in the market. I shall apply that to one of my subjects or one of my sample, and then I shall apply the questionnaire or the instrument that I am trying to develop on the same sample. Now I shall be getting two results, and I will try to understand what is the deviation of my scale, what is the deviation of my questionnaire. If the error value,
Before you move further,
yeah,
so that means the already proven method, like whatever this already has been taken as a base or something like that. So what is the success rate and everything is already available with us. Like those kind of parameters only are taking, or test only are taking. That's what you're
yeah. So suppose this Briggs-Meyer test that has been applied to a large number of samples, that has the questionnaire has been alterated so many times, and now this is a standard test, or we can say this is a test which is almost giving me a true value, a true score, almost, because that is standardized after applying on many people. So I'm taking that test which is already available in the market as a absolute test. I'm taking that. Just for explaining this particular formula, I'm trying to say, because there is no absolute scale, there cannot be any absolute instrument or questionnaire which is totally error-free. But suppose I'm trying to develop my own scale, my own questionnaire, now with which I can compare my error term with one already established or already standardized scale, right?
got the point.
Okay. So here, say for true value, we are like true score, we can take one of those scales and we can compare our questionnaire with that, the total variance, and then we can understand what is the reliability coefficient of my instrument or my questionnaire, whether the questions that I am putting in my questionnaire, whether those are reliable to measure that particular personality or attitude of a person or not. suppose what happens in research, suppose there is already one established scale, say this Briggs Mayer I was talking about for personality, or say there are so many questionnaires for OCD, for stress management, there are so many. So suppose I in my research, I want to understand what is the stress level of the academicians in a postgraduate institution. So my sample or my population is not the whole population, right? My population is only those people who are working in a postgraduate institution. So in my questionnaire, certain questions might be, maybe I want to ask certain different questions, whatever is there in the already established stress management scale, because that scale is not, I'm not satisfied with all the questions that is there in that scale. That is maybe applied for a, that is maybe suitable for a manufacturing sector, that is maybe suitable for a say sales person. That is that is not satisfying all my queries which I want to know. So I will put some of my own questions, or I will try to develop my own questionnaire, right? So now when I'm developing my own questionnaire, my own instrument, now I would like to know whether this instrument is reliable or not. Then what I should do? I should take one already standardized questionnaire and I should take my measures and I should compare to see whether it is reliable or not. If the reliable coefficient falls, there is a range. If the reliable coefficient falls under say 8 to 9, that is the best one. If it falls under 6 to 7, then also this is acceptable. But if this is below 5, then that questionnaire is something wrong. I need to rework on my questions. I need to rework on my items. Understood?
So when you say rework on the questions, when we found that the deviation is too much from the true score, or
right.
Until that point, we
right.
need to wait.
Okay. So in base retest reliability, this formula, what I am doing, suppose this is my first test and this is my second test. So we will be comparing the observations, the scores of both the tests and whether those are correlated or not. If those are correlated, the high with high correlation, then my instrument is reliable. If those are like the correlation is less than 5 and all, then this is not reliable. So this is what is the parameters already given. So this 5 to 6, this is poor reliability. 6 to 7, this is questionable. 7 to 8, this is acceptable. And 8 to 9, that is good reliability. So if my instrument, when I am applying the same instrument on the same person after a certain period of time, after a certain time lag, then I'm getting two results, two scores, and I'm trying to see whether those two scores are correlated or not. If the correlation coefficient of those two scores is more than 7, then I can happily accept that yes, my instrument is reliable. That's why usually we do a pilot survey with a less number of people. Then again, we try to moderate our questions, try to put certain questions, try to get rid of certain questions, or you can say items, to make our questionnaire the best one, with which will be reliable one, which will be a valid one. So okay, now there are you able to see the screen? Like I'm not able to make it a full screen thing. Okay, fine. Just wait. Yeah. So are you able to read whatever is there in the slide? There is a question. Are you able to read this?
Yeah, reading it. Yeah.
Okay. Then take your time and answer this.
I think it's answer. Not I think because of the error is increasing by default. Reliability coefficient should reduce because the factor has been increased. So maybe if it is 1.3, maybe it will become 2.7 or 3.6. That's my answer. Is there any option?
These two are only two numbers given. This is for the true score, variance of true score, and this is for the variance of observed score. So it's asking you that if the variance of observed score, this increases, that one, then what will happen? So this coefficient of reliability is variance of true score upon variance of observed score. This is the denominator. So obviously, if this will increase, then the coefficient of reliability will decrease, right? If this increase, denominator is increasing, so obviously the result is decreasing. Should I move on?
Yes, ma'am. Understood.
Yeah. Now this is one more question. And one hint is, in the formula, this was given. You can take the hint from the formula of calculating coefficient of reliability.
I think it is still on slide number 12.
Come again.
No, you are still in old screen. You have to move to the next screen to see the question.
Couldn't get it. What? Come again, sir?
It is still on the first question, ma'am.
Still, we are seeing the old question 3.9, 1.2. You said that
Still showing the old question.
Yeah. Go to the third slide number 13 now.
Now, should I stop share and then reshare again?
Maybe try that.
Or maybe just escape from this full screen. I don't know. Whenever I try this full screen, something happens. But here you cannot see this. Okay, let me try again.
No, now it came.
Oh, it came.
Yeah.
Yeah, now. The question is, the variance of the total score equals. Can you see this slide?
Yeah.
Yeah, so these 3-4 options are given. You need to tell me which is the correct option.
Kind of, I'm lost here. So
From reliability, validity only, people start getting lost. That is a common phenomenon. So this is the variance of the taste score equals to what this is asking. So see, reliability is what? Reliability is true score upon taste score. Now we are assuming, or hypothetically we are thinking, that there is no error in the true score. Now whatever is my observed score, that is having certain error. Now if I add this error with the true score value, then obviously this will give me the observed score, right? So the variance of taste score, this is equal to the variance of the true score plus the variance of the measurement error. So when I am adding this measurement error with my true score value, this is becoming my observed score, and reliability is true score upon observed. It's not exactly true score upon observed score. It is the variance of true score upon the variance of observed score. And what is my observed score? That is my true score plus the measurement error. So this is option A. Now, if
Hani, before you go further, when you say test score equals, so that means the denominator is what you're talking about here, the formula, what you meant, showcase the formula.
Let us go to the formula. And then, So if you look at this formula, this is the variance of true score.
Again, not refreshed. We are still seeing the question page only.
Okay, let's wait for some time. This my internet connection, I think, is not that much. Not that high speed one. Are we at the formula page now? Or else let me just escape from this view. Yeah, now is it
now it is
okay?
Now it is, yeah, now it is.
Yeah. So see, this reliability coefficient, what we are seeing here is the variance of true score upon the variance of observed score. X is my observed score here. So variance of true score upon variance of observed score. Now what is this observed score? This is the variance of true score plus the variance of errors. If I add on my error with the true score, then it's giving me the observed score, right? What is my observed score? That is whatever instrument, whatever questionnaire I have developed and I have applied to my sample, then I got some score which is having some error. Now this score is my observed score. Now what I'm trying to do, I'm trying to see whether my instrument is reliable or not. So I'm trying to against the true score value. So in true score, I hypothetically I thought that true score, or hypothetically I accepted, thought is again an unscientific word here. Hypothetically I accepted that true score is giving me a result which is free from error. Now if I add on my error with that score, then it's giving me the observed score, right?
No, I got it. I think I got confused with the true and test terminologies. The denominator is a test score.
So anyway, I shall be preparing one more quiz on this so that the confusions reduce. So this is the same thing. What is this question was asking me? So the variance of the total score equals to what? So this is the same thing in the formula, whatever we just saw, just explained. This is the same thing. Just read it once. So this variance X is the variance of the observed score. What is this? This is variance of true score plus the variance of error. This small e is representing error. This t is the true score variance, and this is X is the observed score variance. That is this. So with this retest reliability, maybe
So
we
X
should
is
finish
the
the class
observed
today.
score, no?
Pardon?
Right? The X is the observed score.
Right, right.
The true
X
score is
the
actual score obtained by the person. For example, if the person is obtaining 20 on the scale, the 20 is the true score.
So this is basically, I am trying to get the variance because I want to see what is the deviations, right?
Yes, ma'am.
Yeah. So this T is the variance of true score. And yes, whatever scores you are getting, suppose in a standardized instrument, that will be the, when we apply the standardized instrument, we will get some variance in that thing also, right? When the sample will answer, from the results we'll get some variance of that particular scores. So we will pit my questionnaire against that true score. That is the main thing. And this same concept, test to test reliability, we already covered, that when I am applying my instrument, my questionnaire on the similar sample after a certain time gap, whether my questionnaire is able to give me consistent value or not. If it is able to give me consistent value, then this is reliable. So how we will find the consistency? We will find out the correlation between those two scores. So if this is giving me a high coefficient of correlation, which should be at least more than 7, we saw that the range is given in between 7 and 8, that is acceptable. And if that is in between 8 and 9, then this is highly reliable scale. So this is how I can test whether my instrument, whether my questionnaire is reliable or not, if I am forming a new questionnaire. So this is test reliability. And reliability in terms of stability is the same thing. When I'm measuring, I'm repeatedly applying my instrument in a future date, so the result should correlate with the previous results. So with this, maybe I think we can okay, this is how these are showing just in pictorial representation of test retest reliability. So let me just go for a, okay, let's just get this. That was good enough. Yeah. So this is test 1 question scores. This is test 2 question scores. Then we will find the correlation coefficient, and if that is more than 8, in between 8 and 9, then my instrument is highly reliable. This is a pictorial representation. Okay, this alternate or parallel and other forms of reliability, maybe next day we can do. Right? Any questions?
In the classroom, even this slides also been uploaded, right? Google
Yeah,
Classroom.
yeah, I am. That is a lag from my side only. The slides I shall upload.
Okay.
Scales of measurement, I think 1, and then this reliability, right?
Sure.
So I shall upload the whole presentation, and we will continue. We will finish this in the next class. Only a few concepts are there. That is the internal consistency of the test, internal consistency or internal reliability of the test. External we have covered. So that is the thing. So I shall upload it. So if you want, you can go through that, and I shall be uploading one quiz also. I think the last quiz on scales of measurement was good for understanding, right?
Yeah, it was.
Yeah. So one more I shall be uploading. Okay, then we call
Okay.
it
Yeah.
a day. Okay.
Thank
Okay.
you. Cheers. Good night. Bye.
Thank you. Good night.
Thank you.